Hey there, this is JC. Welcome to my channel. Today I want to talk about what is the Apache Airflow sensors. So here I wanted to give you high level of the workflow of the Apache Airflow components. So you are the users or you are the developers. So who's going to develop the DAGs? Okay, so DAG is a Python file stored under the Apache DAG folder. So we have this component here is Airflow scheduler. So this one, we're going to read your DAGs and start to scheduling your task and read your DAGs and start to scheduling your tasks. Then once it's scheduled, they're going to send it to the queue. The queue going to schedule task to the Airflow workers, right? So any information they're going to be updated, like your DAGs information, just Dagger generate information, right? And also your Daggers, status, whatever, they are going to store into the Airflow metadata in here, right? So this database is going to be used with the Airflow web service UI. Then as our users, we're able to monitor our DAGs and check the results, right? So this is not important, but today I want to talk about what is the sensor, right? So let's move into. All right. So here I want to talk to you. So I will dive into of the schedule box. So we're able to see we have the tab layer. Actually, inside of the Airflow scheduler, so we have three kind of the box or components or services, anything. You can then add it. So top one is scheduler, middle one is the executor, and the bottom one is the DAGs class sensors. DAGs is a large box representing the entire workflow, which contains multiple tasks, including sensors. Like I already mentioned, top layer, scheduler, middle layer, executor, bottom layer, DAGs plus sensor, right? So what is executor? The executor runs tasks and workloads, okay? It decides which tasks, including sensors, should be executed based on the scheduler's instruction. Sensors here raise in DAG presenting sensor tasks. Sensors are specific conditions to be met before downstream tasks persist. All right, so each component in here is interconnected to show the flow of the information and the task execution within an Airflow architecture. This setup ensures that the sensors can efficiently monitor conditions and control the workflow based on the specific criteria. All right. Okay, so list is the definition of the sensor. All right. So sensors are specific type of the operators in the Airflow that are waiting for a specific condition to be true before they success. So we have some key concepts. So if you have the sensor, right? So they have some key concepts here. So POC interval. Okay, sensors use a polling mechanism called a POC. At each interval, the sensor checks whether the condition is met. If the condition is met, then the sensor task is marked as success. Otherwise, it waits and POCs again until it either success or the timeout. Okay, keeping in mind here, right? So let me repeat. The sensor task is marked as success. Otherwise, it waits and the POCs again until it either success or timeout, right? Another one is timeout. Sensor has a timeout parameters which define the maximum time to wait for the condition to be met. If the timeout is reached, the sensor will be failed, and the task will be marked as failed as well. All right. So rescheduling sensors So this one introduced in Airflow 2.0. Rescheduling sensors can fill up the worker's slot when waiting. This is done by pushing the sensor to the schedule of the rescheduling, reducing the load of worker, right? External taggers. So sensors can also be configured to react to internal events, such as a message in a queue or the specific file creation event, using more advanced integrations in here. Okay, so another one is the type of the sensor. So right now, I just list some common sensors in here. Okay, so we have time sensors, that time data sensor, time sensor, file sensor, database sensor, external task sensor, HTTP sensor, and also custom sensors. Right, in my list slides, I'm going to provide to you what exactly of each sensors. All right, so here is a time delta sensor. All right, so this is the wait for specific time interval before persisting. Okay, so in here is they're going to have waiting for 5 minutes, going to store the sensor, and then going to start the process. Right. So the second one is time sensor. So if you see this example in here, so they have a target time, which is the 9 a.m., right? So at the 9 a.m., they're going to trigger the reserve job because they're listening the time, okay? They're listening time, whether they are reached to time or not. If no, they're going to waiting. If not, if yes, they're going to start a list task. File sensor. File sensor here is they're waiting for a file to be present in a specific directory. So from the example in here, and we have the file path in here, so which is they're waiting for this exactly path in here, and to monitor this file under this path, they are to be present or not. Okay, so they have a poke interval, which is every 10 seconds. They are going to trigger and to start another one listening, okay, until the timer in here. Timer here, which means the 10 minutes. All right. Okay, SQL sensor. So SQL sensor waits for the SQL query to return our desired results. So we have the connection ID in here. We also have the SQL in here. So which is what? They're listening, they are waiting for here until this SQL, the return, the results for us. Okay, so this is kind of like what? Synchronous event. Okay, synchronous event. Also can say we're waiting for something to happen, right? Okay, so it's different concept. All right, external task sensor. They're waiting for task in another task to complete. So this one actually is very useful. So in this example, we provide external task ID, right? And also external task ID. So here is so this one, why this one's very useful, because if you have if you're working with another team, so the team, they provide some functionality in the deck, okay, and then you are listening, right? So you want their team to finish something, then you can working on something else. So this is we can leverage the external task sensor in here. But here you keep in mind, okay? So HTTP sensor waiting for HTTP request to return a specific static code or content. All right, so you have the REST API, or you're going to use another third-party APIs. Until this third-party APIs return the data, which is exactly you wanted, right? So the last one is the custom sensor. So this is the example here is we are going to create a customer sensor by subclassing base sensor operator and the implementation the POC method. If we are going to working with our customer sensors, we needed to read developer or overwrite the POC in here. Okay, so this is just the example in here. I will talk to this one detail in my next video. Okay, all right. Next one, I want to give you the very simple demo for the file sensor and the time sensor. I have the time sensor here. So time sensor is going to be triggered after 5 seconds. Okay, and then we are leverage a batch operator to create a file. And in the meanwhile, we have the 5 sensors here. So this is 5 sensors. They are listening the specific file in under the directory. The file to be present or not. If yes, they're going to print log if the file exists. So this is very simple. Okay, so this is a very simple demo. Then, so once both of them are success, then and they're going to go to the next one is I'm going to remove the temporary file. Okay. All right. So let's working on the demo. All right. So here is the demo. File and time sensors demo. Okay. Let's go into it and see what's the code look like. Okay. We have, like I mentioned earlier, so we have time sensor. The time sensor is going to be triggered or we're going to return true after 5 seconds. After 5 seconds, once they return true, they're going to process the downstream task. So downstream task here is a create temporary file. Okay, if you see here, and just get the string hello world to the hello world.txt file. In another branch, I have waiting for file sensor, which is waiting for this file to be created. Okay. All right. So the POC interval here, so this 20. So this one should be 20 seconds interval between POCs. So which means what? So every 20 minutes, they're going to invoke another POC. Okay, until the time after 3 minutes here, right? And then once they detect this one success, which is they say it's going to return true, which means we are able to move to the next task, which is persistent file task. In here, we print out in our logs if the file exists or not, with the exist functions in here. So once we detect that and once we success, and then we're going to delete the file, right? So it's a very straightforward, it's very simple. All right, so then let's name it just to trigger it in here. Right. So right now they're triggering, and you are able to see here everything's running. Okay. Go to graphs. We have the waiting for file to present and the waiting for 5 seconds to start. See, have you seen both of them? They are start running. So we're able to see here, there's time sensor success and also critical file success. Let's see how the waiting for file to print this task, how that look like. Oh, no success. Name is Q in success. Them is Q. Okay, they are success. And let's see in here, since I have the log info in here, I want to check logs. Okay, we have it here, info file exists. So at the end, I want to show you what are the configuration. Okay, Apache Airflow sensors are powerful tools for managing conditional task execution with index. By understanding how sensors operate and they fit into Airflow's architecture, you can design more efficiency and responsive workflow. Here is the sensor as the gatekeepers. Ensure that task persist only when specific conditions are met. Okay, flexible and extensible. Built-in sensor cover a wide range of use while custom sensor offer flexibility for unique requirements. Resource management. Rescheduling sensor optimize resource usage, fill up workers when waiting for conditions. Oh, By leveraging sensors efficiently, you can enhance the reliability and efficiency of your data pipeline and overflow. So I hope this video gave you some value. Okay, see you in the next video.